This is lesson 9A, factoring by grouping, video 2. We were on example 3, so let's go over to example 3 again. We were on E. Miss Carson rewrote this E wrong. It is supposed to be a 6, not a 12, and that's the reason why it was not working in Miss Carson's head. So please erase what you had, and we will do it with a 6 instead. So step 1, again, step 1 is multiplying the outer two numbers, so it would be 6 times negative 10, which equals negative 60. Okay, some factors of 60 would be 12 and negative 5, and 15 and negative 4. And you have, when you subtract them or add them, whatever you want to call it, add them together, you would get 12 plus negative 5 is 7, and 15 plus negative 4 is 11. So these two are your factors that we're going to deal with. And now we're going to rewrite it. Notice that this here, the last sign is telling me my negative will be, the negative 4 is what we're going to use first. So it would be 6w squared minus 4w plus 15w minus 10. And then we are going to break up break them up like we've been doing. So it would be 2w and it would be 3w minus 2. And then I would have 5, and it would be 3w minus 2 again. So again, we have the same thing. So it would be in the first set of parentheses, you would have 2w plus 5. And in the second parentheses, you would have 3w minus 2. Let's try another one. Let's try C. I checked it out. C is fine. I wrote it correctly. So step 1 is write 11 plus 20 times 20, sorry. 11 times 20. And that would be 220. Let's find some factors of 20. Okay, I put the factors above the problem this time. I had 44 plus 5 equals 49, and 22 plus 10 equals 10. Well, 44 and 5 work the best for me. And for, I'm sure, you too, you guys. So I'm going to write it out. I'm going to have 11k squared plus 44 k plus 5k plus 20. Then I'm going to break it up. And it might work, it might not work. You might have to change the 5k and the 44 around, because they're both positives. That it might change. Well, let's check. 11 can go into both 44 and 11, which kind of tells me, yes, they work together. So it would be 11, and then you would have k on the outside. And you would have k plus 4. And then on the second set, you would have positive 5. And you would have k plus 4 again. Yep, that one works again. So it would be 11k plus 5 and k plus 4. Let's try B. Hopefully you have some space somewhere. So you're going to have, I'm going to do this, some of the stuff above B. So I'm going to do 63 times 5 first. And that would be 315. And some factors I can have. I'm guessing 9 might go into it. Yep, I've got 9 and 35 plus 35, and that equals 44. Okay, I know it's 9 and 35. So I'm going to break it up. I'm going to have 63d squared plus 35d plus 9d plus 5. So we're going to break it up. What number can go into 63 and 35? Nothing can. So I'm guessing I did the 35 and the 9 wrong. So I'm going to switch the 35 and the 9. So I'm going to put 9 here and 35 here. So I'm guessing now I can do it. I'm going to have 9d, and then I'm going to have 7d plus 1. And then I can take out 5 because 5 goes into 35 and 5, so plus 5. And it would be 7d plus 1. Yep, that works. So now my answer is 9d plus 5 in the first parentheses and 7d plus 1 in the second. Let's look at example 4. Now we're taking some ideas from example 2 and some examples from example 3 and putting them together. So first of all, what number can be taken out of both 6, 20, and 16? That could be 2. That 2. And then there's a g for each. So now we have 6g squared plus 10g plus 8. We've done it. Now I'm going to keep 2g to the side. We don't need to talk about that because that's a dimension, and so we don't have to see that anymore. So now we have 6g squared plus 10g plus 8. And we're going to do the same thing with that as we did with example 3. So we're going to multiply 6 times 8. And that's 48. And let's find some factors of 48 that will get us 10. Miss Carson made a mistake. It's supposed to be 3. Miss Carson's just having a hard day today. So this is 3 and that is 3. So it's 3 times 8, which is 24. Now we can find some factors of 24, which I can think of 2 that add together to make 10, which would be 6 plus 4, which is 10. There we go. So now we can do it. Let's write out our new 4 term. It would be 3g squared plus 6g plus 4g plus 8. Now I can break them up. Uh, 3g goes into both, and that would be g plus 2. And then 4 can go into both, and that would be g plus 2 also. So here we go. This Carson's just having a hard day. So it would be 3g plus 4 and g plus 2. And there's your answers. So you're going to have, I have up here, I have 2g, then you have a comma, and then you're going to put your 3g plus 4 in a comma, and then a g plus 2, because that's your dimensions. Let's try one more time. Ms. Carson hopefully will get it right this time. Let's do B. So first of all, what can we take out of 3m cubed plus 10m squared plus 3m? Well, none of the numbers will work, but m will work. And so I'm going to put a right with B. I'm going to put the m. I'm going to erase this. And then what's left over? Let's see if Ms. Carson can do it right this time. 3m squared, not 3m cubed. 3m squared plus 10m plus 3. And so over here I have 3m squared plus 10m plus 3. And I can multiply together the first and third numbers, so it's 3 times 3. That equals 9. Well, I know there's only 2 sets of factors. 3 plus 3 is not 9, so I'm going to do 9 plus 1, and that's my factors. And that will be 10. And then I'm going to write out my 4 term, so that would be 3m squared plus 9m plus 1m plus 3. I have 2 sets of terms. Well, 3m can go into the first set, 3m, and that will be m plus 3. And then what can go into both 1 and 3? Well, 1 can. And then what's left over is m plus 3. Again, you have the same. So it's going to be 3m plus 1 and m plus 3. All right, here's your answer. All right. Talk to you later. Bye-bye.